Hi, in this tutorial I will continue to discuss the data introduction in fruits. I already started this with the previous tutorial, but now I'm going to show you a new example of a mixing problem. Actually, this mixing problem has some similarities with the previous one. We have one target and we have three sources, and in this target we have two proxies. Carbon and nitrogen isotopic ratios measured in an amino acid which I call amino acid 1. This is just as an example. Now the sources contain the same amino acid 1, and that's our fraction. And in this fraction, two isotopic signals were also measured. That's the carbon and the nitrogen isotopic signal, like in the target. Okay. Now you might be thinking, we have two isotopic signals in the source, and yet we are only defining one fraction. Well, you can do this provided that the elemental ratio of carbon versus nitrogen is constant across the sources. And since I'm assuming that this is always the same amino acid, well, actually I'm imposing that it's always the same amino acid 1, this necessarily has to be the case. Okay? If this was not the case, then you would have to define two fractions. Now the question that I'm asking is the contribution of amino acid 1 from each source. And this allows me to ignore their concentrations in the different sources. If I was asking the contributions from each source as a whole, then I have to take into account the concentrations of the amino acids in the different sources. But since I'm not doing this, this is a concentration independent model. I'm assuming that there is no isotopic fractionation, no isotopic offset between target and source, so it's an offset independent model. And since we only have one fraction defining the signal in the target, this necessarily has to be a non-weighted model. There's not a second fraction that could also contribute to a target signal. Okay, so non-weighted model. So let's define this in fruits. And I have here a window of two windows of fruits 2.0. So we start off by defining the model options. It's a non-weighted model, it's offset independent, and it's concentration independent. Okay, and I leave the remaining options as they are. We have one target, three sources, one fraction, that's our amino acid 1, and two proxies, that's the carbon and isotopic ratios measured in amino acid 1. Then we click proxies, and here we write the name of our proxies. So let's say proxy 13C and proxy 15N. And then we press apply. Target data, I have that here. Control C, paste data, apply. Sources, the names for the sources. Source 1, source 2, source 3. Okay, apply. Source fractions, that's the amino acid. I will call it amino acid 1, as in the PowerPoint. And then offset weights. We define this as an offset independent model, so no isotopic offset between source and target. And so fruits will set this value to 0, and the associated uncertainty will be kept blank. It's also a non-weighted model. So fruits will say that the carbon signal in the proxy and the nitrogen signal in the proxy, they are fully determined by amino acid 1. And you cannot edit this, and this cell for the uncertainty is kept blank, and also you cannot edit it. And you press apply. Source values. Now, we have here our three different sources, each having the same unique fraction, so source 1 amino acid 1, source 1 amino acid 1, and source 2 amino acid 1. Okay. Here on top you have the name of the proxies, and this is really just to help the user knowing which values to plug in here. So the proxy 13C, okay, well, that's determined by the carbon isotopic signal in the source. So the values to plug in here are the carbon isotopic signals in the source for amino acid 1, because that's the only fraction that we have. And then the associated uncertainties. In a similar way, the proxy 15N, well, the signal of the proxy 15N, that's determined by the nitrogen isotopic signal in the source. Okay, so here the values to plug in are the nitrogen isotopic signals for the three sources and the respective uncertainties. And I have these values here. So actually this would be source 1, 2, and 3. Okay, and these are the values and respective uncertainties. So for carbon and for nitrogen. So I'm just going to do Control C and paste. Okay, and then press apply. Concentrations. Now this is a concentration independent model. So fruits will set these values to 100 and you cannot edit these cells. Okay, then press apply and then press estimate. And then again we wait a few seconds. And here are the estimates. Okay, so the box plots for the contribution from the different sources, the results report, the probability distributions, let's put this in a smooth area, color-coded probability distributions. Let's go back to the result report. So this is the input data, and these are the different estimates. And for this very simple model, we only have to consider these estimates here. I'm going to copy paste this into an Excel sheet. Okay. So contribution from source 1, that's 0.59. So this is expressed in 0 to 1. So this is actually 60%. This is 30. This is 10, and it matches the values that would be expected. So 60, 30, 10. Okay. And that's it.